Today, with the continuation of the last class, we are going to see the economic dispatch problem. Is that economic dispatch problem? So, in this economics dispatch problem, we are neglecting the losses. What is the losses? Suppose if all the generators are in a same unit or a same power plant, then we can neglect the losses. And what is including the losses? Suppose if you're if for the entire power system, if a generator is not in a single place, if it is in the different places, then we need to include or consider the losses. But in first case, we are going to neglect. So whatever the things we are taking for this class is neglecting the losses. Neglecting the losses. So first thing we need to understand, we are neglecting these losses. In question, if they are asking don't consider the losses, then we can proceed with this. Otherwise, next in next class or next to next class, we are going to see how to including the losses we can perform. That we will see later. So if the economics dispatch problem we are considering without neglecting, then first we need to consider what is the cost to generate the power. So cost is nothing but, we already know that C of PGI for any given generator. What is the cost? Is nothing but A plus B PGI plus C PGI whole square. So this is nothing but rupees per hour for individual generator, not for all the generators. It is for an individual generator. Suppose if you want to calculate for all the generators in the unit or all the generators in a power system or a power plant. In a power plant, we may get around 5 to 6 generators also. Some it is purely depend upon the facilities available there. So this value is nothing but to find out the cost for only one generator. If that is the case, so what is the total generator value? So the total cost for the entire power plant is nothing but, the total cost C is nothing but generator starting from 1 to n number of generators. You just add all the individual cost of the generators PGI. So this is nothing but the total cost of that particular power plant. In that power plant, you may get n number of generators. If you add all the cost individually and if you make a summation, then I will get a total cost. So this is very simple. This is a universal law, right? And then how this cost should be? This cost, our economic dispatch problem is aim to minimize. Our aim is to minimize. So what is the objective function? Objective function is nothing but what you want to make to this cost. So I want to make this cost to minimum. So what is the objective function is? So I will write here objective function. Okay, I will write here only. Objective function, I will simply call as OF. Objective function is I want to minimize this cost, MIN. I want to minimize this cost. What is this cost? Cost is nothing but the summation of all the cost of n number of generators. This is the total cost. So I want to minimize this. This is my objective function. And then while solving this objective function, I need to have a constraint or limited to or subject to. So this should be done with a constraint. So what is constraint? What is the constraints of online class? The constraint of online class is I can't able to see you in the directly I can't able to see you, only through laptop I need to. Anyway, my objective function is to complete my class, or I want to convey the information about the subject to you. So that is my objective function with the constraint of still I can't able to see you, I need to complete my classes. So this is my constraint. So like that, even though if you want to minimize the cost of the economic dispatch, still have a constraint. I can't able to just like that turn off all and then it is minimized. I can't able to tell that. So the constraints are, we can call this as subject to or ST. I will call subject to or ST. Okay, fine. I mean, recall this terminology whenever I am telling. So this is subject to. First is this PGI min and then PGI max. In between this only I need to operate my generator. I cannot able to come below this. Below this I can't able to come, or greater than this I can't able to come. So it is, this PG must be bounded between this minimum and maximum, that we know, because all the generator has its own. This is also I means for any generator it has its own minimum and maximum. So this constraint I need to take care. And then one more constraint is I need to meet the demand. Say for example, this is the demand PD, it is asked by the our consumer. I need to always ready to supply my total power generator for it is summation for all the generator with among the generator I am having in the power plant. So if you add all the power it is generated should be equal to my demand. So whatever the demand is required, I need to ready to produce or generate those demand. These constraints also I need to take care. So this is subject to 1, this is subject to 2. So I need to minimize the cost by always thinking my or always not breaking the constraint. Within the limit of the constraint I need to minimize this cost. So this is the economic dispatch problem. Any doubt up to this? So this is the problem we are given to us, how to do that. And by solving I am always neglecting the losses. I am neglecting the losses. I am not including the losses because I am assuming that all the generators are in the same power plant, so that I can able to neglect the loss. In future classes you are going to include the losses also, that I will come up later. So any doubt in this objective function and constraint? Any doubt up to this? Please tell in the, you can unmute. No, good. So there is no any doubt. So how to come with this solution? So how to operate or how to come with this solution for this problem? This is the problem given to us. Problem is to minimize the cost without breaking the constraints or subject to matters. So to solve this type of problem, we have a method proposed by Lagrangian. So that is nothing but Lagrangian. He proposed a method to solve like this problem. Actually he not given the solution for this problem, but still we can able to use this method to solve the problems like this. Like economic dispatch problem we can solve using this method. So if we want to include this method or Lagrangian method, we need to understand what is Lagrangian. So for that I will introduce a small problem statement to briefly understand about the Lagrangian method. So for example, if your objective function f of x is to minimize x square plus y square, minimize, this is minimize problem. Always this Lagrangian is only for minimization problem, not maximization problem. So Lagrangian method is only for the minimization method. So if your objective function is to minimize this f of x with subject to x plus y is equal to 10. Means you put any value for this x and y, you put any value, no problem, but the total if you square it plus and y square, if you add these two, then it should be a minimum with subject to x plus y is equal to 5. So what are all the possible way to get x plus y is equal to, I will get 1, x is 1 plus 9 is equal to 10, that is possible, and then 2 plus 8 is equal to 10 is possible, and 3 plus 7 is 10 is equal to possible. So we will get n number of values. This is subject to, all this x of y is subject to this constraint. I can't able to put if it is not subject to, then I may put 10 plus 11 or 1000 plus 11. So this I can put, but this is all, these are all the not value or not constraint, this is not coming into the constraint, so I can't able to use this, but these are all in between the constraint. Among this value, which is the minimum? So for example, if I take case 1 or this is case 1, if I put, I will get 1 plus 81 is equal to 82, whether this is the minimum or not. Otherwise, if it is this case, then 4 plus 64, whether this is the minimum. So like that I can get all the values, and then I need to find a minimum value. Among this I need to find out which is minimum. So this is the problem statement given for this. So to solve this problem, Lagrangian given a solution for this. Lagrangian, during this Lagrangian method, I can still find out a solution. Yes, it is correct that by giving this value or making all the possibilities, I can find out which is minimum. It is possible, but if it is more variables, we are getting more variables and more functions, and subjective values are more than 1 or more than 3, then that time we can't able to solve by using the normal calculation. We need to have a systematic approach. So because of this problem statement or like this solution, Lagrangian given a method for this. So let have a small idea about this Lagrangian. Say for example, this is the example I am taking for Lagrangian method. So example for the Lagrangian. So what Lagrangian is telling is, he forming a augmented function. First step, you need to take a augmented function. Augmented function is nothing but this is separate equation, this is separate equation, and this is objective function, and this is constraint function, and this is equality constraint, and there are non-equality constraints also, but thank God we are getting that equality constraint. If this is the equality constraint and this is objective function, this Lagrangian function must include x comma y comma lambda, a new thing it is given lambda. This lambda is nothing but lambda is the function of g, and what is this g is nothing but the constraint. This is the constraint. So x is it is a function of objective function, y is the function of objective function, this lambda is a function of constraint. So what this Lagrangian is doing is, he augmenting both the objective function and then constraint in a single equation, and what we will get? We will get f of x function. This is f of x is nothing but this function, he taken this function minus lambda of the constraint equation. What is the constraint equation here? This equation I can write like this, x plus y minus 10 is equal to 0. I can write as it is, right? If I take it, if I taking as a 0, then this will be your g, and lambda of g is nothing but x plus y minus 10. Clear? And if you solve the same equation of x comma y comma lambda, this is the augmented function coming from both the objective function as well as the constraint equation, and f of x is nothing but x square plus y square minus lambda x plus y minus 10. So if you solve this equation, still we will not get, then what we need to do is, we need to differentiate this equations with individual values, individual variables. Say what are all those? For example, if you differentiate with this equation with respect to dx, and then if you differentiate this with dy, and then I am writing here, if you differentiate this equation with d lambda, we will get 3 equations. Am I right? We will get 3 equations. So what will be that? What will be that? So if you differentiate this this equation with respect to x, then we will get 2x. This will be there, and this will be 0, and this will be lambda, right? So this will be lambda. In this lambda, I am having only one x, so I will get this lambda alone. So I will get 2x minus lambda is equal to 0. And if you differentiate the same equation with y, then I will get 2y minus lambda equal to 0. And then if you differentiate with this with lambda, then only this constant will get, because others are 0. Then I will get x plus y minus 10 is equal to 0. So if you are taking this as equation 1, and then if you are taking this as equation 2, and then if you are taking this as equation 3, and if you try to solve these 3 equations, I will get the value of x, y, and then lambda. So if I try this try to solve these 3 equations, definitely I will get the value of x1, x, y, and lambda. And then if you reapply this equation with this main value, that is the optimized value. If you apply this value after solving this x, y, and lambda, if you are giving that value to this equation, then that is the optimized value. That is the optimized value of x and y. So at that time, you can clearly, without any doubt, you can tell that the final value of this x and y is the minimum value without breaking the constraints. So without breaking the constraints, I will get the minimum value of this x and y. So this is a small example to understand what is a Lagrangian method. So Lagrangian method is nothing but creating an equation that is an augmented equation from your objective function as well as the constraints, and if you differentiate those variables which is available in that particular equation, and you will get a n different equations. With that n different equation, if you try to solve those equations using a calculator or anywhere, any method, you will get the variables values. This variable value is the optimized value. We will call this as the optimized value without breaking the constraints. Without breaking the constraints, we will achieve our objective function. Okay, any doubt in this Lagrangian method? It is just an example to understand how this is going to be helpful. And with this input, now come back to our original problem statement. So what is our original problem statement? Objective function, anyone recall? Objective function is to minimize the cost, to minimize this equation I is equal to 1 to n and ci pgi. So this is the objective function, and subject to I is equal to 1 over n, and this is pgi is equal to pd. We need to give this demand. And what is one more objective function? Sorry, one more constraint? It should be limit. One more object constraint is this pgi should be equal to pg max and then pg min. So this is one more constraint. So these are all the 2 constraints or subjective values we need to consider to our objective function. So this is our objective function. Okay, so how we can able to apply our Lagrangian method for this? Now coming to the Lagrangian method, by Lagrangian method. Let's write a augmented equation first. So what is the augmented equation? Augmented equation is nothing but, okay, by now we omit this, because this is actually going to be done, because this generator is not going to be operated more than this, or more than rated we are not going to operate, because we know what is the range of our operation. So we will omit this constraint, we will take only this constraint. So if I write this constraint in another words, I will write like this: I is equal to 1 to n Pgi minus Pd is equal to 0. If I take equality constraint, so I may get this is the constraint. So this is my constraint, this is my objective function. So with this, if you are writing the Lagrangian equation, it is the nothing but the augmented of your objective function as well as the constraint. So I will take the objective function first. Objective function of this nothing but I is equal to 1 over n summation of Ci Pgi minus this lambda g. What is g here? This is nothing but g. So lambda of g is nothing but this one. So lambda of summation of I is equal to 1 over n and then Pgi minus Pd. So I will take, so this is my Lagrangian equation for our original objective function. So for our original objective function, this is my Lagrangian equation. Suppose for the kth generation, for the kth generator, if I want to remove only the kth from this equation number called maybe L1, let it be equation number L1. In this L1 equation, if I want to remove the kth generator only away, so I can split like this. So Lk is equal to, I will take in this summation I will remove only kth element. So Ck Pgk, if I remove this one, and the rest of the things will be I is equal to 1 to n, and I is definitely not equal to k because I removed the kth element outside, and then Ci Pgi minus lambda. Here also in this summation also I am going to remove the kth element, so that Pgk plus summation of I is equal to 1 and I is not equal to k out of n, and then this is Pgi minus Pd. So this is nothing but simply I have removed the separately I have removed this Pgk and this Pgk from this equation. Everything is same, and we know that what is the cost equation? We know that the cost equation is nothing but Ck Pgk is equal to A plus B Pgk plus C Pgk whole square. So this is nothing but the cost equation, just I applied for the kth generator. If that is the case, the above equation is this one, this equation, wherever you are getting this value, so this value I am going to replace with the cost. So if I replace with this cost, the remaining part I will get. Therefore Lk is equal to A plus B Pgk plus C Pgk whole square, and then the rest of the things are same, plus summation of I is equal to 1 and I is not equal to k over n, and Ci Pgi minus lambda Pg k plus summation of I is equal to 1 and I is not equal to k over n, and then this is Pgi minus Pd. Okay, so if you differentiate this with Pgk, so what is the next as per the Lagrangian, what is the thing we need to do? We need to differentiate with the corresponding variable. So what is the corresponding variable here? So the corresponding variable here is nothing but pgk or pg. For the pgk, this kth generator only I need to find out, right? I need to find out for the kth generator. So if this is the corresponding equation or for corresponding variable, then I need to differentiate this equation lk with respect to pgk. So finally I will get dlk divided by or differentiate with dpgk. pgk is equal to, then wherever I am getting the pgk, that element only will come. So here one pgk is there, and where else, and then here one pgk is there, and remaining thing is not. So here also one pgk is there, and remaining thing I will not get. If I differentiate this is the constant, so I will get only b, because this is only one element here. So b, if I differentiate this, I will get plus 2c pgk, and if I differentiate this is the constant, so I will get only 1. So I will put minus lambda is equal to 0. So this is nothing but, as from the Lagrangian theorem, I got this one. And still if I simplify this to find out the lambda value, then lambda is nothing but b plus 2c pgk. So this is very important. So lambda is nothing but b plus 2c pgk. So this is known as, finally this is known as coordinating equation. And if you look, this equation and then incremental cost equation looks same. These both are same. If you identify, if you recall, this equation is nothing but, it look like it is same as incremental cost equation. So this is again a benefit or simplified version to solve the objective function. Okay, up to this any doubt? Up to this any doubt? So what is the use of this lambda and how this lambda is going to be used, that we will see within a minute. But up to this any doubt, if you ask, if you have, you can ask to me. Please yes or no, then only I will move to the next slide. So this k is nothing but for only one generator we have find out. If you want to find out for other generator, just put that generator value and find out what its corresponding c and b value, you will get this lambda. Why this lambda is useful, now we are going to see. Up to this any doubt, please tell me how we derived this equation. Any doubt? Any doubt, you can ask me now, please. Soon tell yes or no, please tell me. Vinod Chaudhary, are you there? Raksha, you need to respond in audio, then only I can, because if I want to see the chatting, then I need to come to here and I need to find out. Please respond me in audio only. Unmute yourself and you can respond. Okay, then only I can identify whether you understand or not. Okay, I have audio problem. What about Thomas and others? Divya, Altamesh, Pasha?
Sir, no, hold on, sir. You can continue, sir.
Yeah, please tell me, respond me, then only I can identify whether you understand or not. Okay. So up to this we have derived a lambda value from by using the Lagrangian method. Now we are coming to a real solution, real analytical solution. How we can able to solve this objective function? Our objective function is nothing but to minimize the cost. So how analytically we can able to use this lambda value to find out our objective function. So very important, note down. So I'll change a little bit color. I'll change to purple. Okay, so analytical solution for lambda. Again, this is very important, without loss. I am not including the loss. Without the losses only I am doing this. Please note down that. And we know that from the lambda value, from the last Lagrangian method, we have derived the lambda. So we know lambda is equal to 2c pgi plus bi. So this is the lambda value we derived just now. From this, if I want to find out the power generated of the ith generator, then lambda minus bi divided by 2ci. So this is nothing but the power generated, right? And then we know the power balance equation. What is the power balance equation or constraint? So I will write power balancing, otherwise you may call this as constraint also, no problem. So this is nothing but all the summation I is equal to 1 for n, whatever the power you generated should be equal to the PD. Otherwise, if you want to make this 0, so I will take minus, and then so this is the power balance equation, right? So from this power balance equation, if you solve or if you apply this PG from here, then I will get I is equal to 1 over n, and PG is nothing but lambda minus bi divided by 2ci minus PD is equal to 0. And if we remove this lambda and bi separately, the same equation I can write like this. So lambda summation of I is equal to 1 over n, and this is 1 by 2ci minus summation of I is equal to 1 over n bi divided by 2ci is equal to PD. So I am taking PD outside as the equality constraint. I have taken the PD outside. From this equation, if I still want to find out the lambda, from this equation still I want to find out the lambda, then lambda is equal to this will come here plus this will come here, and then it will come down in reciprocal. So if that is the case, then PD plus summation of I is equal to 1 over n bi divided by 2ci whole divided by summation of I is equal to 1 over n 1 divided by 2ci. So this is the final lambda value, final lambda value. So this is very important equation. Note down, this is very important to actually solve the analytical solution. This lambda is going to be used actually for solving the analytical problem. Okay, so note, I hope you are writing in your note also. So this is very important. Any doubt up to this? Any doubt up to this? Any questions?
No, sir.
Good. Okay, now I will come up with an algorithm. So you know how to find out the lambda. Now if we systematically going through an algorithm to find out the economic dispatch for without for considering without losses. So I will write an algorithm for that. If you go through this step, definitely we will get someone need to mute itself. Some noise is coming. Someone's noise is coming. Please mute yourself. So I'll write an algorithm for this. Every time I am mentioning without loss, so don't get confused. With loss is different method, without loss is different method. In this also there are two cases. Suppose in the question, case 1 is, just a minute. In case 1, if the limits are not given, what is this limits? That is called PG min and PG max are not given. In some question you will they may not given this. If that is the case, you need to follow the steps. So what is the steps? Step 1. Step 1, note down clearly, assign initial trial value. Of lambda. So we can always start with some random lambda value. Otherwise, you don't want to get more iterations, or the conversion should be taken place very fast. Then you calculate lambda value by using a formula. What is the formula for lambda? Using lambda is equal to PD plus summation of that, just now we have derived that, I is equal to 1 over n bi divided by 2ci whole divided by summation of I is equal to 1 over n 1 divided by 2ci. So using this we can find out the lambda. And then step 2, find out the lambda first, and then step 2, compute PGi corresponding to lambda. So what is the PGi formula? We know what is the PGi formula. Recall, someone tell me. PGi is nothing but, this also we have derived, lambda bi divided by 2ci, and for all I is equal to 1, 2 up to, it will go up to n. So this is what we need to do. So for particular generator, for any ith generator, what is the power generated? You can able to easily calculate if you know the lambda value and BC value. Just substitute it, and then you will get for this ith. And then step 3. Step 3, I will make this as partition. Step 3, compute all the summations, all the generators power, all total generated. I is equal to 1 to n, whatever the power you have generated, just all this. So from step 2, whatever the ith value you can do, you just put a summation for that and you will get this step. No, very simple. And then step 4. Step 4, check the power balance equation. So what is the power balance equation? Anyone just recall first? Power balance equation is nothing but summation of I is equal to 1 to n PGi, that is the generated power, must be equal to PD. So this is the demand they require, and this is the power you generated, and we know what is the value from step 3. We will get this value. This is from step 3, we will get this value, and if it is equal to the whatever the demand they required, then we achieved the solution. Then by checking this, if the power balance equation is satisfied, then optimum solution is obtained. So that is the optimum solution, because whatever the pi at the step 2 you got is optimum. In step 2 you know how much power I need to generate for different generators. So if you find out that, and if it is satisfying the step 4, then step 2 values are correct and those values are optimum, first condition. Otherwise go to step 5 that we are going to do now, or otherwise next step we need to go. What is next step? Next step, that is step 5. I will start from here. Step 5, right? There are two conditions in step 5. One condition is if summation I is equal to 1 over n PGI is lesser than the demand required, means the total power generated is less than the demand, then, and one more condition I will write that also, else I will write here, else if there will be three conditions only. One, it should be equal, or it should be less, or it should be greater than. PGI or n is greater than PD. Only three conditions you will get at this step 4. If it is equal, we will stop up to the step 4 only. Otherwise, it may be less than, or it may be equal, or it may be greater. Then during that time, what is the solution we can write is here, then find new lambda value, and for formula for this new lambda value is nothing but del Pg divided by I is equal to 1 over n and 1 divided by 2Ci. So this is nothing but change in demand. So how much demand we requires? For example, it will have some say for example, if it is less, how much less it is? So that is nothing but this Pg. If it is greater than this, how much differ? How much greater? That you need to put here. So this is nothing but change in demand, or how much the old value it is changed. So this is nothing but change in demand. And then after finding out this lambda, you need to update new lambda value as the old lambda plus change in lambda. You find out this value and you know already what is the lambda you used at step 4 or step 3. If you add this 2 lambda and you update this lambda, then after updating, go to step and go to step 2. We need to continue with step 2. After updating this new lambda by adding the old lambda plus delta lambda, then go back to the step 2 and follow. Okay. Otherwise, else if this generated power is greater than the demand, then again find new del. This is also same formula. So how much change you need, that you put here, Pg divided by summation of I is equal to 1 over n 1 divided by 2 Ci, and then update the lambda minus change in lambda and go to step 2. So you will get. So any doubt up to this? Step 5, you need to you may get two conditions. If this is the case, you do this, otherwise you do this. So this is very, very important. this one is if it is greater, and if this one is if it is less. So any doubt in this algorithm? Any doubt in this algorithm? Yes or no? Please tell me.
No, sir.
Good. So I will do a small problem on this. We'll solve one small problem. I think we have 5 more minutes. I will solve this problem very fast. So this is the second problem. Or I think we have one more class in afternoon. I think we can solve this problem in the afternoon. Okay. So up to this I will stop the class. So up to this algorithm I'll stop one more class you are having at 3:50 I hope. Am I right? So at that class I will solve the problem. Okay, any doubt up to this? If you have any doubt you can ask me.